Hello and welcome to my video for the second video lab report for Physics 114 Spring 2019. Today I will be talking about forces and summarizing the different types, specifically the 7 different types that we discussed and learned about in class. The types of forces that I will be talking about and showing real-life applications of are weight, normal, spring, tension, friction, both static and kinetic, drag, and thrust. The first force that I will be talking about is weight force. Weight force is signified by F, meaning force, and G, gravity. The calculation for weight force is mass times gravity constant, which is 9.8. And the gravity force, or weight force, is the force that an object exerts on the surface or the earth, that is the earth, due to its mass. Any force or any object in this picture is exerting a weight force on the surface that is resting on, or the earth. But today the object of focus is the dog, my dog. He is exerting a weight force on the ground, but the ground is also exerting a force on him. This is called normal force, signified by a capital M. This force points upward, like this. And this force is often it has a atomic level, just the same as weight. And these forces cancel each other out in this situation because the dog is not going up or down. There is no vertical motion or movement, which means that normal force equals Fg, or weight force, in this picture or in this situation. So, to summarize, weight force is the force that a object exerts on the ground or earth, and it is pointing downward. And normal force is the force that a surface or earth exerts on an object pointing upward. Now, if there is no vertical movement, there's no vertical movement, the forces equal 0. To show spring force, I've decided to use a simulation, as this is one of the easier ways to show the force of springs. And as the name suggests, a spring force is most commonly observable through springs. So here I have a spring, and it's already all wrapped up or hanging here in this simulation, and I will add a 100-gram weight here. I'll go ahead and add on the string and spring, and what happens is it bounces up and down. If we put it on slow, we can kind of see a little bit easier. So the spring recoils, and then it goes back out and then recoils again, and it just repeats this over and over. Now, if we increase the weight to, let's say, the max, which is 300, the spring pulls out a lot more, and when it coils back in, it's a lot tighter, as we can see. Force, to record spring force, the easiest way to do it is you take the original measurement of the spring, which we can see that we're going to round it to roughly about 50 centimeters. We take our mass, I'm going to use 50 grams, stick it on there to about 50 and drop. Then we can go ahead and pause it. At the bottom, and we can see it has it is at 75. So the area between 50 centimeters and 75 centimeters is the area that we measure when calculating spring force. Spring force is directly related to the length and the tightness of the coil. Now, the weight of the object also has to do a lot with the force, because the heavier the object, the more that the gravitational or wave force pulls on it and puts more force into the spring, as observed here. So spring force is a force that is stored in something like a spring or an elastic, and increases as the elastic is pulled, or the spring is pulled, or maybe is pushed, and it will increase the amount of force in the spring, and this is how we get movement. So this is spring force. In this clip, we can see a rope pulling a wood block. This is an example of tension force. The force from the string that I am using to pull the block is what is moving the block. Tension force can be seen in many different areas, including pulling a rope, tug of war, tension bridges, and things like this. Tension is denoted by a capital T. Here I am going to be demonstrating friction, both static and kinetic, using this tin. This tin has quite a few objects in it, so it is relatively heavy. So when I go ahead and try to push it, just with a slight force, it doesn't move. The force of my hand is pushing. It also has the weight force of the that we talked about earlier, as well as normal force. Again, we talked about those cancel each other out. So what is keeping my force from moving this? It's static friction. So my force is going this way, and static friction is going back. And because I'm not applying enough force to move it. But once I apply just enough force that to overcome that static friction, it becomes kinetic friction. This is why when I push it, when I let go of it, it will stop because of kinetic friction. The friction that allows it to come to a stop. In this clip, we can see a piece of paper dropping to the ground. And this can show us the force called drag. Drag is a resistance force caused by the motion of a body through a fluid such as water or air. Drag force acts in the opposite direction of movement, and therefore in this clip, or in this experiment, the paper's drag force is pointed upwards as its movement or velocity is pointed downwards. So the seventh and final force we'll be talking about is thrust. Thrust we did not discuss much about in class, but it is a very intriguing force and is most commonly seen in rockets and airplanes. Thrust force goes in the same direction as the velocity of the object of interest, at this point here the rocket, and the thrust force pushes the gas vapors fuel vapors come out of the engine, and then pushing back is the thrust force here, and this thrust force then pushes the rocket up into space. Now, to counteract the other forces of weight and drag, the thrust force has to be very great to be able to launch the rocket the proper distance. So, you can also see that in a plane. If we want to just draw a little plane here, there is also the thrust is going in this direction towards the movement in the same as the velocity of the airplane. And then we also do have drag back here, as we talked about, and weight. There also is a lift force, but I won't just draw that in here as we didn't discuss it in class. But this is where the thrust force is. So the engines are pushing backwards, and the thrust force therefore is going forwards in the same direction of velocity. To summarize what we have looked at today, we have looked at weight, which is described by Fg, and the formula is Fg equals mg, and it is the mass or an object's mass's force upon the Earth. Normal force, which is the Earth's a surface's or the ground's force upon an object, and this is often seen with weight because if they are equal, there is no vertical movement, and therefore the object is still in the vertical direction. Spring is seen in things like springs or rubber bands, and for example, it is increased when the spring is condensed or is pulled apart. Tension force is seen in things like cables and ropes when you are pulling something. The rope is the tension force. This is signified by a capital T. Also friction, both static and kinetic. Static friction is when a object is being pushed. A force is pushing up or pulling upon an object, but the friction of the object is keeping it in motion, similar to maybe somebody trying to push a car, whereas kinetic friction is when the object is in motion and the force pushing or pulling it is greater than the friction, but as soon as that force is let go, the kinetic friction will take over and bring that object to a stop. Drag force was represented by a piece of paper falling, and this is in the opposite direction of motion or velocity. It's also seen in planes and rockets, as well as thrust force, which is the mechanical force that causes rockets and airplanes to accelerate and be able to fly. So these are the 7 types of forces that I discussed and that we learned about in class. Thank you for watching.